And welcome to today's webinar. I'm Jamie McCarthy, the Marketing Communications Manager for IOActive and moderator of today's webinar. IOActive is excited to present a live webinar with Brian Singer, Director of Industrial Cybersecurity Services, and Brad Hegrat, Director of Advisory Services here at IOActive. The title of our webinar today is Patching Realities and Solutions for ICS. Please note all participants will remain on mute throughout the webinar. If you have questions for our presenters during the talk, simply type them into the questions box located in the webinar console. Time permitting, we'll have Brian and Brad address some of the questions at the conclusion of the presentation. If your question isn't addressed at that time, we will be sure to follow up with you after the webinar. Thanks again for your interest and for attending today. Take it away, Brian and Brad.
Thank you, Jamie. Pleasure to be here. Brian and I have been doing this a rather long time. We've been working together in some various form or shape for well over a decade now, and we both have quite a bit of experience in the space. We're both CISSPs and CISMs. Brian's also a CAP. I'm not sure actually what that is. Brian, what is that certification?
Brian, are you there?
Yes. Hi, is that better?
Seems like we're having some technical difficulties.
While we wait for Brian to sort that out, why don't we go ahead and move on to a couple of the slides here.
Sounds great. Here's a summary of our, sorry, go ahead, Brad.
I was going to say, as I said, Brian and I have been doing this quite a long time. We're both veterans in the space. We're both U.S. military veterans as well. And we like to mention that because it brings a little bit of a different mindset when we start talking about the protection of critical infrastructure for our space. Next slide, please. So while we're thinking of patching and patching being the foremost of the subject matter for today's webinar, there has been a number of improvements over the past 15 years or so in the space. We've seen all manners of network architectures, products, services, and things of that nature come onto the space. But at the end of the day, the concept of patching is still something that needs to be done. Even with all those advanced products and services pushing forward into the space, the idea of patching the systems, because that is ultimately engineering out this vulnerability from this complex system. Next slide, please. So what if there was a better way, right? What if there was a different way that we can deal with these particular challenges in the space from a security perspective, so that we didn't have to maintain this rigorous patch cycle as much as we have to. Next slide, please. So when we talk about industrial control systems and SCADA infrastructure and critical infrastructure in general, patching only as the defensive strategy isn't really a strategy. And we'll talk a little bit about this a little bit more in depth later in the webinar, but we're dealing with engineered systems. This is the concept that these systems are engineered from the standpoint of a process engineering or chemical engineering, and things of that nature, so that all those variables are accounted for. But when we get into the OT side of things, we find that they're not always as well engineered and robust as we would like. And as we say here, ICS security isn't really security as we know it today. It's a lot of essentially going back to the basics in some respects. Next slide, please.
Yeah. All right, really quickly, can you guys hear me now?
Yes. Welcome
Okay.
back.
Here we go.
All right.
All right. In fact, this is Brian Singer. Sorry about that, folks. Apparently, we got the technical issue eliminated, however.
Excellent. Welcome, Brian. So what was that CAP certification that you hold?
Oh, yeah, Certified Automation Professional. It's a certification for the ISA organization, the same group that runs the ISA 62443 standard for industrial security.
Excellent. We'll talk about that standard in a little bit. But back to the deck here. One of the things that we always like to drive home is that there are advanced threat actors out there, and they exist, and they're inside your environment. They're coming in from the outside as well. They come in all different shapes, sizes, and forms. And as the slide really says, it's very much a perpetual and omniscient style of threat. It's always going to be there. And the only way you're going to be able to deal with this level of potential incursion into your environment is to have that level of vigilance, that level of preparation that will allow you to deal with these threats on your worst day here.
Yeah, and Brad, kind of to add to that, I mean, I think it's a fallacy for people to think. I mean, I still hear it all the time. People say we want to be cybersecurity. We want nobody to hack us. We want to make sure that we're totally invulnerable to any type of attack. I'm like, well, that is not really a very feasible goal. A comprehensive security program includes three things: your preventative controls, your detective controls, and your reactive controls. And a lot of folks want to think that we can stop everything. Well, the reality is that we can't. The nature and shape of attacks all the time change. If you look at the bottom left, you see a very recent ransomware that ravaged all over the world, and it was something we were largely, well, I mean, even though we knew about the vulnerability a couple of months before it hit, the systems were largely unprepared to deal with, and so it was a new threat vector. So again, the key is preparation is key. I like the statement there. Preparation is key. Vigilance is required. Risk is never eliminated, and it's much more important for us to have good detective ability and good reactive ability than it is just to make sure that we've done the prevention ahead of time.
And as we say here, the key word is risk, and we know that there's a number of ways to deal with risk, a number of ways to address risk. We can do any number of things to try to deal with the issue, but at the end of the day, ignoring risk is not an option. It's not one of the four things that you can do here. Next slide, please. So when we talk about patching, we know that patching in the industrial space is hard, right? We're not here to try to tell you that you have to patch or that patching is your only option. But in the core manner of things, the idea of patching is about removing vulnerability from a system, programmatically removing vulnerability from the system. And as much as we hate to do it, everybody's got to eventually get to that point. In the case of the malware that Brian just noted, there is a capability within that particular that malware piece, as well as other pieces of malware before this particular variant, that have brute forcing and keyboard and login caching capability, so that once it finds a set of credentials that work, it can manually spread itself from one node to the next, irrespective of whether or not the box is actually patched. So sometimes it doesn't even matter, and that's something that is very troubling to the defenders of industrial control system environments, because while we can't always patch and keep up to the latest standards, just because sometimes operationally it's just flat out not an option, we have to be able to have some level of plan moving forward.
Yeah, I think, Brad, that's actually a really good point. You look at your last point there. Sometimes it's flat out just not an option. Well, why is that? I mean, what's the problem there? You know, especially for industrial control systems, a lot of times we're dealing with a heavily validated, tested environment. And it's the concept of mechanical integrity that comes over from the safety world. For those in the United States, that would be regulated by OSHA, Occupational Safety and Health Administration, and they say that you have to have mechanical integrity in a process. You have to be able to control all the things that go into and out, and you have to understand what the threat model is, what are the things that can potentially go wrong. And so we do deal with a lot of times that people look at, well, I was able to get my system quote unquote certified. That's not entirely the correct term, but I was able to get my system basically certified with a mechanical integrity that you know, I know how everything works on this. And if we start to apply patches, especially if they go against what the vendor tells us to do, that can potentially interrupt the operational stability and mechanical integrity of the process. And kind of going to the bottom right there shows us a quick, easy Shodan. Most folks on the line are probably familiar with Shodan, the Google's version of the hacker's version of Google. That was just a really cursory search looking for port 445. These recent attacks on Petya and WannaCry, they were able to perpetuate over port 4045. So this just shows you really quickly, very simple search, what does the potential size and scale of the problem look like? And that is just the tip of the iceberg. Just looking for machines on the internet that are talking on port 445. And if those were not patched, they're potentially vulnerable to some of these most recent attacks exploiting the MS-17 010 vulnerability notice.
So we talk about what if there's a better way. Well, the only way to get another option around the idea of patching is to engineer the system with the ability to have an operational mode that allows for some level of degradation of service. At which point that engineered system allows for a different operating mode, if you will, in the event of a particular event for that hinges on access via patching. So this only works though if we engineer these systems the proper way.
Yep.
Next slide, please.
Okay. Yeah, our current design methodology is quite flawed in many ways. I mean, if you look at it, you know, there's too much emphasis on the traditional IT design methodology. We tend to kind of follow the adage of, you know, what do you mean I'm out of money? I still have checks. You know, and you still see that, you hear this a lot of times. People goes, what do you mean I'm out of network? I still have ports to plug into. And so they tend to follow more of a genetic growth model by growing the network, adding switches, adding components, adding machines as they need, without a lot of thought into it in terms of, you know, or what are our real needs? What kind of impact is that really going to have? How does this impact our operational stability? What type of reliability and resilience do we need out of our network? So and then the downside is because we don't really plan. I saw a great joke the other day. It said, you know, hours of coding can save you weeks of design, right? Well, weeks of coding will save you hour design. Sorry, I got that backwards. And so we see this happen a lot in the OT space as well. That people go through, they kind of build everything, they play around with it until it all works, and they go, okay, well now that's the baseline. So they do the factory acceptance test, they do the site acceptance test, the pre-startup acceptance test, and then they start the process. And once it's up and running, they're like, oh, well, we had to turn all that security stuff off while we were doing this, and we didn't patch anything, but now we're operational, so we really can't do anything about it. So the last point on the slide is, you know, everybody's afraid of what we call the 2 a.m. Bubba problem. And me being from Alabama, I get a little bit sick at that statement, but hey, we'll deal with it. You know, everyone's terrified of 2 a.m. Bubba. Who is 2 a.m. Bubba? Everybody's terrified of the person. They're like, we don't want somebody running at 2 in the morning without when the rest of our folks aren't in, having to make some type of operational change. And really, at the end of the day, this is just not a very acceptable answer. You know, we need to have systems that have been designed, validated, and commissioned and properly planned so that we follow an intentional network design methodology. That everything in the network should be aligned with our operational safety goals, should be aligned with our efficiency goals. And you know what? We already do this for all of our engineering assets. We know what the mean time between failure on components is going to be. We know if we put them under test, what the resilience of those components is going to be to certain type of electrical change, vibration, noise, and everything else. And then we just kind of throw our hands up in the air when it comes to the network and to the operating system and the patching, because people just don't really bother to look. Well, the reality is that all the information is there and waiting for us if we really just take the time to look for it. And if you follow a few practices, it is entirely possible to design a system that where your network and all of your operating systems and your process are all fundamentally aligned into one resilient strategy.
So that makes a lot of sense, Brian. When we start talking about network design, we'll get into this in just a moment, but understanding the functional requirements of the control system itself is very key for ensuring that your design is appropriate for that particular problem.
Yeah. Yeah, and the last point is the most key on that one, is that in IT, we use information to drive business decisions. In OT, we use information to drive physics. And so when you're telling a person why you can't just, you got an IT person that comes in and says, just apply this patch and reboot the system, you need to help them through the process of understanding. We're not just we're not just stopping email here. If it takes 200 milliseconds to get your email, nobody notices. It takes 200 milliseconds to get a process control instruction, and we might fail safe the process, or we might cause something worse to happen. So again, real things happen in the OT space, and you need to be prepared for that.
So let's talk a little bit about the differences in the network infrastructure themselves. While both infrastructures use Ethernet and TCP/IP as part of their technology set here, the difference between the two is that we operate on a very fast technology refresh in the enterprise space. We are constantly adding new servers, updating network gear. The endpoints are constantly changing. There's a lot of ebb and flow with respect to the technology as well as the users in the enterprise. In the industrial control space, in the ICS systems and SCADA systems, unfortunately, we have to drive these things for a great number of years, often on the scale of 2 decades or more. And because that is the case, things like these vulnerabilities, MS-08, 067 for the configure and Stuxnet vulnerabilities, all the way out to MS-17-010 for the latest round of ransomware outbreaks. We have to have some level of strategy built into the network itself if we're going to get to the point of having any level of resiliency to these systems. Again, this is an engineered system we're dealing with. We should be able to predict every packet that gets put on into the environment. If there is a place where IDS and IPS technology actually has a shot in trying to get this security feature to actually work and work well and reliably, the ICS space is pretty much tailor-made for that level of technology.
Now, Brad, that 15 to 20 year time you see up there on average system time, I know that's been the traditional time, but that time seems to be shortening. What kind of technologies are out there that's really starting to drive that change to move that average system age down?
Well, from an embedded standpoint, we're still seeing a very long life cycle from the I hate to call them IoT style devices, but the embedded devices that are out there doing last mile control and telemetry collection, things of that nature. But when you start to look at the traditional OT style of technology, things like virtualization and as well as the Microsoft operating system in and of itself are driving a very much a shortened life cycle or lifespan in some of these technologies. The nice thing about Microsoft's decision after XP is that they ran that operating system for a very, very long time. And Microsoft, after that operating system was essentially put to bed, they came out and said, you know what, we're never going to do that again. We can't afford to ride that horse that long and that far into the future. We need to go on a much more dynamic upgrade schedule. So this is driving a lot of the industrial control system vendors' methodologies around MES systems and HMI systems and things of that nature to a much shorter lifespan and life cycle, where they're constantly having to keep those technologies up. Likewise, you're starting to see the adoption of virtualization technologies, and we'll get to virtualization in a minute for a strategy to get around patching. But virtualization technology is one of those things that allows us to be much more agile and risk-friendly, if you will, for dealing with some of the things that we have to deal with in the industrial space. It allows us an opportunity to test environments in such a manner that we did not have the opportunity to test for them in the past. Does that answer your question?
Pretty well, yeah. Yeah, so I really think, and it's been said several times now, and we want to really drive the point home that, a lot of people approach the OT security problem with an IT mindset, which is fine. We use the same tools and techniques. We use a lot of the same, same types of technologies, a lot of the same vendors and names of technologies. The difference is in the OT side, in the IT, like I said, if it takes 200 extra milliseconds to receive an email, nobody even notices. In the process control, 200 milliseconds can be the difference between fail-safe or it'd be between a running operationally in a fail-safe condition or something even potentially worse. So, really the point we're trying to get back to is, in everything in a control system, systems are not just built, they're engineered, they're planned, they're tested, they're designed, they're thought through. For everything that we say, well, all right, fine, we need to make this many widgets an hour, we design the entire system to make sure that we can achieve making this many widgets an hour. Right, and for anything that we can measure, like predictable failure on drives, motors, controllers, like we have things like lubrication schedules on machine to make sure that we keep them operational and running, preventative maintenance. All of these things we can measure. We already have processes that are really well in place, really well established and documented. But for some reason, as I already kind of mentioned, when it comes down to the network, people kind of toss up their hands. Even though the information is waiting there to be seen, a lot of people just go, well, it's the network, we don't really know. Well, so the reality is, and what we've seen, Brad and I have been working together for the better part of 15 years in industrial networks. We've seen the good, bad, the ugly, and the really ugly. And what we've learned over that time is every process event, every packet, everything happens for good reason. Everything there can be measured if we bother to do so. And if you plan your network and your architecture out correctly, not only, but basically you're going to have control over what data is flowing where and at what time. You're going to understand what's going on. You're going to be able to diagnose your communications of why things are failing. And the reality is also is that if you plan it well and you secure it well, you are going to help preserve your operational integrity and lower your need to patch overall, because again, you're going to have limited the exposure. If you do not have port 445 exposed to the internet like we showed earlier, then guess what? You don't have to worry about those particular attacks coming in the short term. There's still long-term things we have to worry about, but at least in the short term, we know that we're isolated against those types of events.
So we
both would agree there's a better way.
Right, and we talked a lot about the network, right, and a lot of things that we can, at a high level, we can do to the infrastructure to alleviate some of the pressures from patching. However, how do we actually do that? The how in this particular point is the key question. In order to look at your industrial environment and try to get a handle on the OT aspects of these features and functions and devices that live in this environment, we have to have a solid understanding of the industrial process itself. Far too many times we get to the point, like as Brian mentioned earlier, we get this engineered system and we look at it from a chemical or process engineering perspective, and it's elegant, it's designed well. But then what we do is we peanut butter spread this technology, this OT technology, across the top of it, and it's not really well engineered to fit with the particular process engineering items that live essentially under it. So understanding the process itself, understanding exactly what dependencies from an industrial engineering perspective are present within each system, and then identifying the OT aspects that live on top of that system and mapping those as close to as possible is your real key to the success. And it's not just, as the slide says, it's not just about Windows, right? It's about understanding the network. It's about understanding your firmware and other field devices that you have out there. We often say that all devices are not created equal, but a lot of times, at least in the IT space and many times in the OT space, people say, oh, it's a PLC, it's critical. Well, just because you have one brand of PLC, you may have 6 of these things, it doesn't mean that the criticality of the industrial process is identical for every one of those 6 PLCs. You have to look at the criticality of the process as well as the devices that live in the process.
So, really, for us, everything really boils down to a solid network design. I've built, plenty of greenfield and brownfield processes over the time. Brad and I have worked on a lot of this together. Again, I think, we kind of jokingly talk about the fact we've got war stories on several continents now. Well, that is the reality. Is that we've deployed these networks, we've designed these networks, and if you do it correctly from the beginning, this does not have to be that onerous of a process. It's just adding a few additional steps in that really can be done largely in parallel with the existing engineering process. The key is, though, you don't got to like it, you just got to do it. Right? And a lot of people, they're kind of resistant to the idea of doing the industrial network design, following the requirement specification, following those recommended practices, because they don't understand it. Well, the reality is, in the world, that doesn't have to be an answer anymore. There are plenty of resources available. There are lots of good standards out there, like the ISA 62443 standard, like the NIST cybersecurity standard, NIST cybersecurity framework, 853, 882. I can go down the list of plenty of documents out there that are great to help with this. There's lots of folks out there. There's plenty of resources within our own organization, within lots of other organizations out there that can really help you with this process. Engineering begins with requirements gathering. We're already doing the requirements gathering. Let's go ahead and get the right requirements to the network side as well. We're already doing a process hazards analysis and a HAZOP in a lot of, especially in safety regulated environments. If we're doing the impact analysis to understand what's going to happen if a valve does not properly open, and what type of preventative maintenance we have there for that particular valve or that part of the process, why don't we go ahead and model what communication requirements for there as well? Say, hey, we need to make sure that we're able to communicate with that valve within a certain amount of milliseconds. Well, I can design a network that will accommodate that design constraint. But we don't want to just kind of go, well, we want it to make sure it works and then just hope that it does. A big mistake that's often made in industrial networks is people design, build, and test them largely in a vacuum, and then they connect it to the rest of the network. And then they wonder why things change. It's like, well, you can't really necessarily plan those things out. You have to accommodate for all the other things that can go on in a network. So ideal design incorporates one-to-one process to network mapping. I should know what device, what needs what information, and what type of a data array. I should be able to plan that out. I should be able to say what's the reliability required on that piece of that component, how critical is it to operation, and then I need to back that off of there. Why am I using a 20-year-old layer 2 unmanaged switch if I can't be down in a particular area more than a few seconds or it's a potential safety issue? If I see those issues, or I know it's going to cause a downstream impact, then at that point we ought to be talking about redundant networking, redundant controls, having failover strategies and switches so they back themselves up, having cold spares, hot spares, warm spares, whatever we may need to make sure that we can maintain operation if there's some type of adverse condition. So for us, it's lots of subnets. I'm sorry, Brad, go ahead.
I was going to say, but Brian, that sounds like complexity. It sounds like an extra unnecessarily complex engineering effort. Why can't I just go on using the same layer 2 subset that I normally use?
That is an objection we often hear, and I have never once in over 15 years heard it to actually be true. It is fear-based politics right there in the beginning. Nobody actually finds it. I mean, what they say is, oh, this sounds like it's going to be so onerous. You're already doing every one of the steps that we're talking about doing here. We're just not necessarily looking at a few additional things for the network, right? And then not to mention, I mean, I've never had anybody come back and say, oh, wow, that was really hard and we got done with it, and now nobody knows how to manage it. Well, the reality is things do not change that much in an industrial setting, and we really can get down to a fairly granular control of what message and what time needs to be in what location. Now, let's also look back at this. Roll back 10 years, roll back 20 years when everything was analog control. We still had to guarantee all the inputs and outputs, the gazentas and gazoutas, for every single control out there, especially in a safety environment. We're not really expecting anything that much different than we've done before. It's just a matter of, again, you don't got to like it, you just got to do it. So kind of wrapping that up on there is, we want to make sure we push layer 3 layer 3 services down as far as possible. Lots of virtual LANs, isolating communications. If I don't want process line to talk to process line 2, 3, and 4, then if I don't want malware to spread between those, I probably ought to do something to isolate those from never being able to talk to each other, right? I need to understand the timeliness of the data, where the data has to go, and then make the topology enforce that. It is no different than the processes we did 20 years ago and 20 years ago or further in analog systems. It's just a matter of designing the network with that. We need to design the network with the potential failure in mind. What would be the impact? What would go on? What would happen if I lose connectivity of one particular switch? Cables get cut. Malware hits the network. What would be the impact if I lose those communications? Those communications are suddenly manipulated. We're already doing that impact analysis everywhere else. This is not adding in a significant amount of more work. It's just a matter of needing to do it.
So the best part about pushing layer 3 services down closer to the actual endpoints and IO devices is that should a security issue arise, you have the ability to dynamically spool up layer 3 ACLs to block whatever threat is inherent in the network. Now, it's a lot of engineering to go block those by default, and that's one of the #1 pushbacks we get, especially from a design and commissioning standpoint for these style of infrastructures. But if you have the ability to do it, it at least gets you to the point of having a defensible position later when the event occurs. Next slide, please. There we go.
Okay. Okay, so I think, you know, one area, there's several strategies out there. You know, when we're going to talk about those a little bit. So, you know, design is kind of the first one. The second one is, you know, we've had a lot of customers that what they have done is they have, a lot of industrial settings are going to have primary and secondary operation center. They have primary and secondary control or emergency operations centers as a bit of your patching strategy. And what we've done now, probably in several dozen cases over the past few years, is that what we've done is, you know, if you want to have an emergency operations center, that's great. Have a hot standby site, that's fantastic. I think it's a fantastic idea, especially in most you know, critical infrastructure settings. But what do we all know? If you're going to have an emergency center and you're going to have failover procedures, what do you got to do? You have to test those every once in a while. So one of the recommended practices we've started to evolve and found to be very effective is we'll kind of kill 2 birds with 1 stone. You'll have primary and secondary control rooms. So what you do is you have your primary site, you go ahead and you exercise, you don't do anything, you don't patch any systems yet. Exercise your disaster recovery plan or your DRP plan, fail over to your secondary site, fail over to your emergency operations center. Once you're up and running in the emergency operations center, go ahead and patch the original primary environment, test it out, make sure everything works okay, and then fail back to your primary. And then the last step would be to go ahead and patch the emergency operations center at that point. That way, you get to exercise your disaster recovery plans. You get to manage your patch strategy. And if all else goes wrong, you are actually operational on your secondary site, and you can fix the primary before you actually have an impact from the patches.
So this only makes sense though if you have a network that can support it, right?
If you have a network that can support it, absolutely. I mean, again, that's you know, and I mean, you and I have both seen this. How many times we've been to a site that they have a standby and they haven't tested it, they haven't communicated with it, it's not patched, and then you get out there and you find out they have more problems failing over to the secondary, and I'm like, okay, well, that's all well and good, but it's sure good if we tested this under a controlled condition, rather than when you had a major winter storm knock out half your communications, right? So yeah, you definitely need to make sure that you have the infrastructure to support it.
That reminds me of a time that I was doing a security assessment for a utility in Hawaii. Yeah, it was tough to live in Hawaii for 3 weeks during a security assessment, but essentially it was the same style of mentality here. They had redundancy upon redundancy for not only control rooms but different pumping stations. But when we started to look at the physicality, the location of some of these services, we found that they were almost all of them were in tsunami flood zones. So yep. With that being the case, it's like, well, guys, that's great, you know, but you didn't really solve the major issue, or you didn't solve the major problem that you're trying to engineer around. Yep. And in many cases, that's something catastrophic, like a tsunami.
Yeah, you had one of those. Mine was with Katrina, and we had lots of chemical facilities and oil and gas that were in the zone that got hit by the major hurricane. And a lot of those places, they had fantastic backup and control procedure. They had standby controllers, cold spares. They had lots of spare equipment, and they had fully environment fully ready to go, located physically next door to the primary facility. So the same meteorological event took out both of the primary and the secondary at the same time in several customers. So you have to remember that there is a reason we do business continuity and disaster recovery planning, that we recommend remote offsite storage or remote offsite backup to make sure that the same geological or the same meteorological event cannot impact both operations at the same time.
Right. At this point, we're not talking just about cybersecurity. We're talking about overall process continuity.
Yeah, and isn't that just the job? I mean, that is the job of security for us, though, is it not? Your job is not with the hackers and crackers, oh my. It is the operational stability, resiliency, and safety of the environment, right?
You're right, but everybody likes to focus on the sexy stuff, right? The stuff that gets all the headlines.
Yep. As I always say, your job in security is safe and efficient operations. All the rest of that stuff should get tossed out. Yeah, you're right. It's not nearly as sexy to talk about those things, but it's kind of a, it's a do it once and get multiple benefit. I mean, the same protections we put in place to maintain operational stability of a network are the same things we do to prevent against security attacks most of the time too.
So this brings us to our next slide and our next discussion topic, which is the concept of really taking that TikTok style mentality that you explained with the physical operation centers and try to do something very similar from a virtualized standpoint. Virtualization provides a number of really good capabilities for us to really deal with security issues as well as other operational issues in a much more agile and responsive manner. The idea that if a patch is applied, you can instantly revert to snapshot and get back to some level of operational state in almost real time. Not quite real time, but you are very, very close to real time at that point. It's something that is very, very advantageous for us as defenders of these environments. Additionally, what we find is that, believe it or not, in many cases, systems perform better in a virtualized environment.
Yep.
And given the fact that we have a variety of industrial environments, they're not always the cleanest, nicest, safest places to work, especially from a computing standpoint. Irrespective of the human aspect, some of these places just don't deal well with electronics. So having remotes or centralized computing capability that is then distributed to the different components of the industrial environment via a very robust multi-path switching and routing based networks. This is something that allows us to have a lot of capability for dealing with very dynamic change within the environment.
Brett, I mean, we said about virtualization of servers, something that's getting overlooked a little bit. I mean, what are your feelings on virtual switching and some of the concerns that we have around that?
So, from my standpoint, you're already talking about abstracting the actual path of the packets when you're talking about physical switching. So, from my standpoint, the only risk with the virtual switch is whether or not the computing assets themselves can get overloaded. So when you're talking about certain network environments in the industrial space, you can have a lot of things like multicast. And if your multicast, for whatever reason, goes unchecked, you can have a very high spike in traffic, which can have adverse effects on certain virtual switches. So with that in mind, we have to take an additional requirements gathering step and engineer the environment appropriately to handle those style of negative events with respect to the network infrastructure. So that said, from an attacker's standpoint, one of the things that I like to do just to exercise an industrial environment during either pen tests or security assessments is to do, I call them the super networking tricks, right? Layer 2 networking stuff. Mess with spanning tree. When spanning tree reconverges, you're going to drop your multicast address tables, which will send, which basically nukes IGMP and send your multicast everywhere. So understanding exactly how the process is going to behave when somebody starts doing things in that manner is a very, very good basic test to understand if your network is engineered appropriately. As you mentioned, there is this concept of organic growth. I said, well, I'm not sure what you called it, genetic growth.
Yeah, right.
Yeah, that concept of genetic growth, right? Where over time you just bolt more stuff onto the side of your existing infrastructure. Well, that's great when you have, the network up on plane from a stability standpoint with IGMP and your multicast just curved and everything. But what happens if you have a spanning tree failure or whatever reason multicast floods the network? You want to be able to ensure that your subnets are small enough so that the network doesn't trip over itself trying to come back up. Yeah. We've seen many times where controllers will flat out fall because they can't talk to their IO devices. And
they're doing exactly what they're designed to do at that point. Yep.
Exactly. They're kicking off, but the industrial process falls over. So that's a perfect example of how this environment needs to be engineered as the rest of the environment does.
Yep.
So with that, there's a number of key takeaways here, right? Focus, and it's not all sunshine and rainbows, because as Brian said, this is difficult. This is hard. We need to focus on gathering the network requirements as appropriate to design these environments with failure in mind. Not only that, looking at the latest technology, knowing that we're going to try to ride this technology for the longest period of time, and look at that from a longevity perspective, to ensure that the technology that we're going to be putting in is going to last that long. And then lastly, we talk about how prior proper planning prevents poor performance, right? Understanding how to control the human aspect of these very complex and engineered systems is something that is very favorable for the asset owner moving forward. That's examples of that include your industrial control system, security-centric security programs, rather. Those types of things are very important for the governance of these environments.
Yeah, and I think at the end of the day, what we're really trying to advocate and push, and again, we've got quite a few years of experience behind this, and seen way too many places that have had very bad days and good days. That really, again, everybody starts worrying so much about the patch we need to apply. Well, we got to patch those. And I'm like, you're absolutely right. You need to patch. But why, if you have disabled all internet access or all email or something like that, or you do not allow certain types of images on the network and you filter all this stuff out, why in the world do you need to worry about that patch right away? We still want to patch, but we're not finding ourselves in an emergency situation where we feel like we have to apply the patch right away. And so what we've really tried to communicate today is really there is a better way. Rather than being purely reactionary into the field of security and network design, you can align with your existing practices. You can, throw in some additional things to do. We're already doing a lot of these activities anyway. Just go ahead and toss in the communications infrastructure overflow, data flow analysis, the requirements analysis, and then testing and commissioning, validating, doing vulnerability assessment and penetration tests on your networks prior to bringing them up live. Because at the end of the day, what we're going to do is we're going to reduce your need to patch. The network is going to be focused upon its operational requirements, and communication data flows are going to be mapped and are going to be enforced electronically. So again, a lot of those things that come out there just are not going to impact your process control environment as heavily as if it was just wide open with no planning and just, like I said, prior prop. Well, you got to give it one more time, Brad, so everybody can hear it. I know the military version, which is not fit for all ears. So
right. Prior proper planning prevents poor performance.
Absolutely.
So that's the key, though, right? We're talking about essentially buying time so that you can be proactive and not reactive. It's having a defensible position out of the gate and not reactionary to every single little threat that may pop up on your radar. Next slide, please. So one of the things that we talk about a lot is, where do you sit as an asset owner? Where do you sit? Are you a security novice, or are you a security expert? And a couple of things that we like to drive home with this slide. Obviously, you can read the differences there around the talent, the capabilities, and the programs. But the key takeaway is that both the novice and the expert company are targeted by the most advanced threat actor. It's only the difference between the two is only the ability to have the more expert level organizations have the ability to see and tactically understand that they are being targeted. But everybody's at risk. Next slide, please.
Again, we see this, again, a lot of people think, well, hey, I need security. Where do I buy that security stuff at? Well, and everybody's heard the security is a process, not a product. Okay, you know what? That's all overused, been said way too many times. The key is that there are several activities that we need to be doing from a security perspective all the time, right? And rather than look at it like a separate process, I tend to prefer to look at it as integral to the process all along. And we've done it, I've done several design builds of new facilities over 18 to 24 to 36 months, where again, this does not have to be an onerous process. The network and the cybersecurity folks are only needed at certain points in the process. And we can talk you through when those points are. But there are some basic activities that we want to make sure are happening all the time. So, you need to have, looking at the left-hand side of that line, you need to have an ICS, Industrial Control Security Systems governance program. Plan for how you're going to manage assets. Identify those critical assets. What data, what information is critical to operation? What safety requirements do we have? What regulatory requirements do we have? From there, you want to develop that into policies, standards, procedures, all of those good things. Those have to be documented. People have to be trained on them. They need to be aware. All right, then we have the industrial secure development lifecycle, that we want to make sure that devices that we put out there have been tested. Not only do we want to know what the vulnerabilities of those devices are and do what we can to resolve those, we want to work with the vendors to understand what the threat models and threat curves of those various components are. Sometimes there are things we cannot patch in those components, and we need to have a compensating control in there in place for that. Then we have process vulnerability management. So, now we have the devices, but we also have the communications infrastructure and the process itself. What happens if I open this valve and change that sensor or deny that communication? We need to understand, what's going to happen if I lose visibility or if that sensor gives me a false reading. We need to look at those things. We've already done this from the safety side in a lot of cases. We just now need to look at it not only from the safety and the entropic hardware perspective, we also need to look at it from what happens on the non-deterministic threats, what happens on the security threats, what if somebody manipulates the value? What if there's a denial of service on the network that prevents that communication, and we get the communication, 30 seconds too late or something of that nature? Then we look into more of the, those are all your basics. Those are the just, if you're not doing these days, we really need to have a talk, right? Everybody should be really looking at some of those basic features these days, or already should have some type of program in place. We start looking at more of the advanced security capabilities, and this is where that we want to engage folks that work with us a lot. You want to have an OSINT program. What is that? Open Source Intelligence Program. That is looking for what is the information you share with the world. What can somebody with limited tools and information you do to figure out what can they do? What can they figure out about your organization? Can they go to LinkedIn? Can they go on the web and figure out a whole bunch of things about your shift operators and your supervisors? Can they use that information against you in a social engineering campaign? Do your website share information that it shouldn't? Do we find I've found vulnerability assessment reports and pen test reports shared on company websites from years past. Well, that's just a great how-to program. So we all know that very rarely are all of those things addressed by the time we find one of those documents. Then you ought to look at your suppliers. Who are your system integrators? Who are your EPCs? Who are the consultants that work with you? And are they providing the same level of protection over your data that you expect of your own organization? More often than not, we find out that one of the best sources of information about how to attack a facility or how to attack a company comes from your suppliers, because they don't normally have the same level of protection. Industrial penetration testing. This is a bit of a careful art. We're dealing with operational systems. Again, information that drives physics. So we want to make sure as we're doing red teaming or when we're doing penetration testing that we're getting a good balance between the information that we can gather, but we're not creating unnecessary, undue risk to the plant. Then we move into insider threat management. Insiders are always going to be a threat, but there are things we can do from training, from awareness, from communication programs, and then from enforcing in policy, both technically, logically, physically, and logically, that we can actually limit the threat, the insider threat. And then overall red team program. The concept of red teaming is to stress test our systems over time, to basically exercise all those plans, find out what will happen, how are all of the rest of those things work together in concert to provide you, again, an assurance of your advanced security capability, of your ability to maintain safe and efficient operations, even in the face of a cyber threat.
Perfect. So that essentially concludes our webinar for this afternoon, it's afternoon for me and here on the East Coast. So with that, I just wanted to give you a little bit brief overview of Bioactive. We've been in business for a very long time now, and we're one of the only companies that provide chip-to-code assessments. And what that means is everything from reversing microprocessors all the way out to social engineering and red team. We do it all. So with that, I'm going to turn this back over to our lovely moderator, Jamie. and she can manage questions from there.
That sounds fantastic. And thank you for the lovely compliment as well. You guys had a very, very engaging talk for us today. I will read some questions now. Hopefully they are relevant to the talk that we've had. Here is a comment from Joel. It says, the problem to me seems to be lack of consistent patch mechanism from vendor to vendor. If you can't patch at all, seems patching is not so valuable. Need to patch platform, Windows, applications, ICS software, embedded devices, controllers, networks, devices, etc. Interested in your views on the reality of this.
Excellent. Thank you, Joel, for the question. We have to address as much of the patching problem as possible. So if we follow our own advice here and look at engineering the network from an industrial process standpoint, we can at least buy ourselves some time to deal with this very complex patching issue. Obviously, the platforms are the Windows platform, for example, is one of the biggest targets. That said, we can provide some level of air cover because there are technologies that allow us to essentially manage and monitor the connections to those environments so that we can actually see when something's attacking them. It gets a heck of a lot more difficult when we start to talk about defending the embedded devices and patching the embedded devices. It's not a clear-cut style of model where we can say if we can't patch everything, we shouldn't patch any of it. But I really think that we should patch as much as humanly possible and take a very proactive defense position to guard the environment from things that we can't protect against.
Yeah, I think, I actually agree with you. There's a lot of inconsistency in how that's done, but there's also a lot of different classes of devices, as Brad was basically hinting to. There are standards out there that are working to help this. ISA 62443 has the Working Group 6, and they have a technical report that they've issued that is actually addressing the issue of patching overall. And, what we usually find is that we develop patch management strategies, and we work with the different vendors, and we're still kind of working with vendors and the asset owners on an as-needed, case-by-case basis. That inconsistency is improving, but I would agree with you, it's still rather immature in its overall life cycle. So at the end of the day, I think we're really trying to recommend that reduce your need to patch is still one of the better defensive strategies we've seen out there for a lot of reasons.
Awesome, thank you for the answer. Let's move on to our next question. The next question is, what about data diodes? Where do they come into play?
Excellent. So data diodes are very, very good pieces of technology that have their place in various different ICS infrastructures. That said, they're not a replacement for certain other technologies such as deep packet inspection firewalls and other application-specific firewalls, because those devices are bidirectional in nature. So depending on the industrial environment, we would want to put data diodes. My personal preference from a design standpoint is multiple diodes lower in the system to protect sub-elements of the process that don't necessarily need to talk out from that environment, but may need to provide data out of that environment. Mm-hmm. Brian, what are your thoughts?
Yeah, I think I would agree with that. I mean, and it goes down to, there are some places where it's regulatory, like in the Nuclear Regulatory Commission, the EDI 0809, they're required between, level 3 and level 4. Sometimes I get the levels backward. So they're actually required as border devices for the nuclear side and some other places. However, we've also seen people use them as kind of we'll just put a data diode in and forget about the rest of the stuff. Well, that to me is not a very acceptable answer. As you said, they're very fit for purpose tools. You got to define the purpose. They're good technology when you use them for a reason. So, and I always boil down to a simple concept of an intentioned network design. And if I have places where I need to move data off securely, I do not care as much about data coming back in, and we'll save the dual-way data diode for a discussion for another time. But there are places where I absolutely would use them, and they are the fit for purpose solution. But we also want to make sure that we're cautious not to treat them as a panacea.
So it looks like we have time for about one more question. I'm going to read that off right now from one of our attendees. And the question is, are all patches created equal in terms of risk? Firmware versus MS-OS patches.
I think we might be able to have room for another question, because the short answer is no. They are not. It depends on the source. I mean, we've seen several times where malware and vulnerability has come out that the vendors have turned around and released a quote-unquote patch that was provided by some third party and not really fully tested. I'm not going to point fingers, but we know that's happened a few times. It depends, and a lot of times it's going to be the nature of the emergency. And if there's everybody around the earth is starting to freak out, well, a lot of times we'll see patches hit that cause more harm than good. We've seen antivirus vendors that have pushed out bad antivirus updates as patches that have caused disruptions to systems. So again, you can't, and not only on the patch side, we often don't really know. I mean, if I'm writing an application, there's libraries, there's applications, there's other thing underneath that. I may not know all the little nuances that are affected by a particular change. And so, we've often seen patches come out that may have an operational impact, and that's one of the reasons we talk about you need to have a standby site, or you need to have somewhere else to validate those patches before they go out. We don't want to call anybody out in the negative, but the reality is it's humans writing code, and humans are going to make mistakes, right?
Great. Thank you for the answer. We have about 30 seconds left. I just wanted to thank Brian and Brad for joining us here with this webinar today. Again, the title of the webinar is Patching Realities and Solutions for ICS. If you didn't feel like any of your questions were answered, please contact us. We're available all the time. You can email us at info@ioactive.com. And we hope you have a fantastic day. Thank you, everyone, and have a wonderful, wonderful week.